Okay, guys, here's our final exam review for Unit 7. Unit 7 was about rational functions, so it's really just rational is a fancy word for fraction, so it's things that are functions that are fractional. So let's take a look. We're going to start with domain. We talked about in the last video in Unit 6 how the domain is all the x values you can plug in to get a defined value for your function. So we're looking for problems. That's the easiest thing to do. And I noticed that I have a radical, which means I can't take the square root of a negative, and my radical's in the denominator, which means I can't divide by 0. So, first thing, this stuff here needs to be greater than 0 so that I don't take the square root of a negative. When I have a radical by itself, I'm going to put a greater than or equal to because the square root of 0 is 0. But in this case, I can't let the square root be 0 because then I'm dividing by 0. So it's just going to be a greater than sign. So I'm going to solve this. I need x to be greater than 5 halves. So I'm going to start at 5 halves. And I'm going to go until infinity. Okay, so let's look over here. My only problem here is going to be when I divide by 0. So let's factor this. Okay. You'll notice I have a common factor. What that means is while this is going to be a vertical asymptote, this is going to be a hole. A hole is still a problem for my domain. So essentially what we learned here is that x cannot equal 3 or negative 2. So I'm going to go from negative infinity until negative 2. Everything between negative 2 and 3 is okay. And then everything after 3 is okay. But I can't have negative 2 or 3 because that'll give me a vertical asymptote or a hole. Okay, we're going to jump into solving some inequalities real fast. Let's see if we can do this. Remember, my goal is to start by finding my zeros. So the numerator is 0 when x is negative 3, and the denominator is 0 when x equals negative 2. So I'm going to make my number line. I'm actually going to rewrite this real fast. I'm going to factor out that 2. That's going to help me in a minute. Okay, and notice these don't cancel out. So here's my number line. I need to put negative 3 on my number line. I need to put negative 2 on my number line. So let's start testing some things. If I plug in something like negative 4, I'm going to get 2, which is positive. Negative 4 is going to make this negative 1. And then negative 4 is going to make the denominator negative as well. I know sometimes in the past I haven't put something for this, like I called that positive. If your leading coefficient when you factor something out is negative, then you do need to pay attention to the fact that that's always going to be a negative. So this is just for habit. But notice I have a negative and a negative. Those are going to turn into a positive. This part's a little tricky. We're going to think about negative 2.5, but another thing you can think about is just something that's bigger than negative 3 but less than negative 2. So when I plug this in, this 2 is going to be positive. If I plug in something that's bigger than negative 3, this is going to be positive. Or for instance, if I were to put in negative 2.5, this would be positive. But if I put something in less than negative 2, again, like negative 2.5, this is going to be negative. So if I only have one negative term, this whole thing will be negative. Okay, my leading coefficient is positive. If I plug in anything bigger than negative 2, this is going to be positive. Anything bigger than negative 2, this is going to be positive. So if like negative 1, all those factors are positive, so that's what we have. Now, notice there's a greater than or equal to sign. Negative 2 is the 0 from the denominator. Negative 3 is the 0 from the numerator. So negative 3 is okay because that's going to make my function equal to 0. Not okay because that's going to cause me to divide by 0. So the shortcut is if it's from the numerator, you fill it in. If it's from the denominator, you don't. Okay? Asking for everything that's greater than or equal to 0, so we want the positives. So I'm going to go from negative infinity until negative 3. I'm going to include negative 3 because it's a 0 of the numerator. And then I'm going to go from negative 2 until infinity. Negative 2 is not filled in, so it gets a parenthesis. Okay, number 4. Let's start by factoring this. Notice in my numerator, I'm going to have an x minus 2 and an x plus 2. over x is less than 0. Okay, I'm just going to jump straight to the number line this time. So I think I can see my zeros pretty easily. I'm going to have a 0 of 0, 2, and negative 2. So now we start testing things. So let's plug in negative 3. It's going to make this negative, negative, negative. It's an odd number of negatives, so this will be negative. If I plug in negative 1, it's going to be positive, negative. We have an even amount of negatives. If I plug in a positive 1, it's going to be negative. Negative 1 will make this positive. Oh, sorry, positive 1, so this will be positive. And then positive 1, this will be positive. I have an odd number of negatives. Over here, everything here, so this is greater than 2, so this will be positive, positive, positive. Okay, that's going to give me positive. This problem is asking me all the places where this is less than 0. So the first thing I notice, if it's less than 0, we don't care about any of those. We won't include them. And I want them, I'm going to go from negative infinity until negative 2. And then I'm going to go from 0 until 2. None of them are bracketed because I didn't want to include any of my zeros. On to the back. Okay, we're looking for vertical and horizontal asymptotes. So just as a reminder, this is places where you have a 0 in the denominator. But make sure you look for holes. Okay, and then horizontal asymptotes is your degree rules. So you're looking for, is it top heavy? Because if it's top heavy, there's none. Is it bottom heavy? If it's bottom heavy, then it's 0. Or if it's the same degree, that's going to be the leading coefficient over the leading coefficient. So let's take a look. First thing I want to do is factor this. First thing I notice is I have a common factor. That means that negative 4, there's not a vertical asymptote at negative 4. It's actually a hole. So the only vertical asymptote that I have is when x is equal to negative 1. And careful, vertical asymptotes are vertical lines, so it has to be x equals. Okay, horizontal asymptote. We're looking at degrees. I notice that it's bottom heavy, so my horizontal asymptote is going to be y equals 0. Let's look over here now. I'm going to plug in, I'm going to factor. So the first thing I'm going to factor out here is a 2. Pull out a 2 here as well. This is special. Okay. Let's see what we've got here. I want to see if I can factor this real fast. We need this to be a positive 1. So I'm thinking that this is going to have to be a 3 and a 2. This is just me guessing and checking. So I know that these have to multiply to 2x squared. These have to multiply to negative 6. So I was thinking, okay, if this has to have a value of 1, it helps if these are only like 1 separated, like 3 and 2. If I multiply 3 by x, I get 3x. If I multiply 2x times 2, I get 4. I need the bigger one to be positive. So 4x will be positive, 3x will be negative. That will give us x in the middle. The bottom, you really don't necessarily have to factor. Well, so it's a difference of, it's not a difference of squares, but 6 is root x squared. So I can rewrite it like this. I know it's a little bit of a weird way to think about it, but that's it if we wanted to put it into linear factors. Let's think about our questions again. The first thing is asking me, what is my vertical asymptote? Or in other words, is there anything that makes the denominator 0 that's not also 0 of the numerator? Well, it's going to be when this is 0. So really what we're just doing, if you want to think of it this way, is I'm saying, what makes this equal to 0? Well, if I solve this, I take the square root of both sides. That's where these came from. So my vertical asymptotes are at x equals root 6 and x equals negative root 6. So now let's do my horizontal asymptote. Let's see. I notice that my degrees are both quadratics. They're both something squared. So I'm looking at their leading coefficients. I have 4 and 2. If I divide 4 over 2, I get a value of 2. Remember, vertical asymptotes are x equals. Horizontal asymptotes are y equals. Okay? That is something I will expect you to know. So now we're moving on to x and y intercepts. So let's see what we got here. X is when y equals 0. So let me make a couple notes here. So x intercepts are when y equals 0, or a shortcut is just when the numerator is equal to 0. And y intercepts is when x equals 0. So we're just going to plug in 0 for x. So let's do my x-intercepts first. We said that's when the numerator is equal to 0. Let me explain why. If y is 0, this side of the equation will be 0. If I want to solve, the first thing I'm going to do is multiply both sides by my denominator. When I multiply by that 0, it's going to go away. So it's really just when 0 is equal to this. So I want to know when my numerator is equal to 0. If I factor out that x, I'm going to get that my x-intercepts are when x equals 0. So when I plug in 0, I get out 0. When I plug in a positive 3, I get out 0. Okay? My y-intercepts is when I plug in 0. So I'm going to have 0 squared minus 0 over 0 minus 2. One's going to give me 0 over a number that's not 0, so 0, that's just going to be 0. So my y-intercept is when I plug in 0, I get out 0. So this was my y-intercept. These were my x-intercepts. Notice one overlapped. Okay, let's do this over here now. Let's do x-intercepts first. So maybe I'll underline these just so they show up better. Okay, my x-intercept, remember, is my numerator equals 0. Hopefully you guys can figure this out in your head, but if I had to solve, I would do this. So my x-intercept, when I plugged in 2, I got out 0, and when I plug in negative 2, I get out 0, because remember, we want it to equal 0. Okay. My y-intercept is what happens when I plug in 0. So if I plug in 0, I'm going to get 0 squared minus 4 over 0 squared plus 0 plus 1. That simplifies down to this. So when I plugged in 0, I got out negative 4. Okay, the last thing I want to do is I want to graph a rational function. So let's jump right into that. When you do that, you're going to want to know what the y-intercept, x-intercept, and the asymptotes are. So let's just do that as a review real fast. Remember, my y-intercept is when x equals 0. My x-intercept is when y equals 0. My vertical asymptote is when the denominator equals 0. And then this is my degree rules. Again, x-intercept is also when my numerator equals 0. So let's do it. I'll just factor this real fast. This will make my job a little bit easier. I know my vertical asymptote is when the denominator is 0, so my vertical asymptote is x equals 4. My horizontal is my x rules, so when I look over here, I notice I have the degree rules. I have the same degree on the top and the bottom, so I do my leading coefficients of 3 over 1. Okay, my x-intercept is when the numerator equals 0. The numerator is 0 when, so if I plug in 2, I should get out 0. Okay, and now let's do the y-intercept. The y-intercept says when I plug in 0, what do I get out? Well, it's going to be 0 minus 6 over 0 minus 4. So that negative 6 and that negative 4 are left over. That simplifies down to 3 halves. So the first thing I'm going to do is I'm going to go to my graph and I'm going to plot what I know. I know I have a vertical asymptote at 4. 2, 3, 4. I might go in and highlight this just so you guys can see. I know in the video it can be tough. I don't want you to actually highlight this on your test if you don't want a solid line. This is just so you guys can see it better. So here is my my vertical asymptote. I have a horizontal asymptote at 3. So again, this really should just be a dotted line, but I'm going to use my highlighter just to make it stand out a little bit better for you guys. Okay. I also know I have an x-intercept at 2, 0, and a y-intercept at 0, 3.5. So remember I told you guys that I need at least 2 points per section. If it's a middle section, like if we had 2 vertical asymptotes, you're going to want 3 there, so you make sure you know cubic-like shape or more of a quadratic-like shape. But in this case, I already have 2 points. So I normally turn my paper to draw this, but I will just do my best. So we've got this thing coming in, coming out, and then down. Well, I need some points here. So this table, I'm not going to grade. It's just there to help you. But I'm going to thinking, okay, let's try what this is. So 1, 2, 3, 4, 5, 6. There's normally an amount of like, it's not symmetric at all, but there's like patterns. So since this was 2 off and it gave me a nice number, I'm going to try 2 off. So 1, 2, 3, 4, 5, 6. We're going to plug in 6. And when I plug in 6, that's going to give me 18 minus 6. That's 12. 6 minus 4 is 2. Oh, that's convenient. That's a value of 6. So when I go over 6, I go up 6. Okay. I'm going to go more. Let's try plugging in 8. When I plug in 8, I'm going to get 24 minus 6, which is 18. 8 minus 4 is 4. So let's think about this really fast. Dividing by 4 is the same as dividing by 2 twice, because this is 2 times 2. So if I divide this by 2, I get 9. If I divide it by 2 again, I get 4.5. This is about 4.5. So when I go to 8, I'm going to go up 3, 4.5. You can see how there's kind of the same pattern. Okay, so I'm going to just kind of sketch this as best I can. Okay. When we graph rationals, remember we're going to have to find these first. We plot everything we know from this, and then we just find any additional points that we need to make sure we have at least 2 points from each section. So I hope that was helpful for you guys. Again, reminder, our test is coming up soon. Let me know if you have any questions.